Okay, let's dive into this. We're about to question one of the most influential books ever written. For more than 2,000 years, Euclid's Elements hasn't just been a math book. It's been the bedrock of logic, science, and our very perception of reality. I mean, this wasn't just some textbook. It was seen as this perfect system of logic, a blueprint for rational thought that influenced literally everyone from Newton to Einstein. Its foundation was considered totally unshakable, eternal. But what if that eternal foundation, that bedrock of science, was fundamentally flawed from the very beginning? That is the provocative, frankly wild claim at the heart of a radical, line-by-line error correction of Euclid's entire work. Now, to really grasp the sheer audacity of this claim, you have to appreciate what's being challenged. This isn't about tweaking a few formulas here and there. No, this is about attacking the very axioms, the supposedly self-evident truths that all of Western geometry is built on. Think about it. Its definitions, its postulates, these were seen as unquestionable truths about how the universe works. The idea of a continuous line, an infinitely divisible space, this was considered the language of reality itself. And now, let's get to the heresy. The source material we're looking at argues that this bedrock isn't stone at all, it's sand. It identifies a set of core concepts not as truths, but as fundamental errors. So the core argument here is that Euclid's whole system is built on concepts that aren't physically real or mathematically exact. Things like infinite divisibility, irrational numbers like the square root of 2, the endless digits of pi. This revision argues they're all just useful fictions, approximations of a much simpler, cleaner truth. So what's the solution? A complete purge. The goal is to eliminate the continuum, to get rid of pi, to replace the very idea of an angle, remove 0 as a starting point, and just banish irrational numbers from geometry altogether. And this table, wow, it just lays it all out, doesn't it? On one side, you have Euclid's world of continuous, kind of vague, and often irrational concepts. And on the other, you have this proposed new world that is discrete, finite, and purely rational. It's a massive paradigm shift, really, from geometry to algebra. So how do you even rebuild geometry without its most basic tools? Well, the proposed answer is to start over from the simplest possible concept, the whole number, and crucially, starting not with 0, but with 1. Okay, so in this new system, a point isn't some abstract dot with no part. No, it's a concrete address on a grid. Think of it like a pixel on your screen or a house on a street. It's countable, it's definable, and it's indexed by a number, starting from 1. Next up, forget length. This system uses something called quadrants, which is just length squared. Now, why would you do that? Because it absolutely kills irrational numbers. Think about the Pythagorean theorem. A squared plus b squared equals c squared. If a squared is 1 and b squared is 1, then c squared is 2. Euclid says the length c is the square root of 2, an irrational number. This system just says the quadrants is 2. Done. The numbers stay perfectly rational. They stay exact. Angles are also thrown out. Yep, you heard that right. They're replaced by spread, which isn't a measure of rotation in degrees or anything like that. It's a simple, elegant ratio of 2 quadrances. And just like that, you turn trigonometry from a study of circles and triangles into pure, clean algebra. And this just brilliantly shows the difference. The old, familiar concept of an angle, which is often messy and transcendental, becomes this clean, dimensionless, and always rational number. It's all about precision over approximation. So we've replaced points, length, and angles. But all of this, it's all leading up to the most shocking claim of them all, a world without pi. Okay, this is really key. Remember, we're on a hexagonal grid now. In this world, a circle isn't some smooth, perfect curve. It's a collection of specific points that are all the same quadrants from the center. And on a hexagonal grid, this shape naturally forms a circumference made of exactly 6 straight-line segments, where each segment has the same length as the radius. Let's just let that sink in for a second. If the circumference is exactly 6 times the radius, well, that means the circumference is 3 times the diameter. The source states that the endless, transcendental number pi isn't just wrong, it's completely unnecessary. It's, and I quote, excluded by construction. Not 3.14159, just 3. But this whole revision isn't just some abstract mathematical exercise. The source material frames it as something much, much bigger. A philosophical battle, a conquest of ideas. You might wonder why go to all this trouble. Well, for philosophical purity, yes, but also for potential real-world applications in fields like computer graphics and physics, where discrete spaces are fundamental. And this is the philosophy that's driving this whole thing. The argument is that correcting a foundational error in human thought is a more powerful and lasting act than any physical conquest could ever be. I think this metaphor is so powerful. A sword's victory is temporary, it's destructive. But the pen, by correcting a false axiom, creates a new foundation, like running code, that is permanent and generative. It's about destroying a flawed idea to build a more perfect one. So what does this all add up to? I mean, if we accept this line-by-line correction of Euclid, we are left with a completely different vision of mathematical reality itself. These are the core takeaways, stated as blunt facts. It's basically a declaration that our intuitive, continuous view of space is just an approximation of a deeper, discrete, and purely rational reality. This final quote really frames the entire project as an act of revelation. The goal isn't just to propose some new theory, but to uncover a hidden truth that was there all along. And that leaves us with a pretty powerful final thought. If a foundation as seemingly solid as Euclid's geometry can be challenged this fundamentally, it really makes you wonder, what other unquestioned assumptions, what other eternal truths in science and philosophy are just sitting there, waiting for the right pen to come along and rewrite them?